How to solve water crisis. Earth is mostly water, about 71% of its surface, but 96.5% of that is salty ocean and only a tiny fraction is accessible freshwater. Even so, about 2.2 billion people today lack safely managed drinking water. Demand is projected to vastly exceed supply. By 2050, roughly 5 billion people, about two-thirds of humanity, could face water shortages. In short, water is abundant globally, but clean water is scarce and unevenly distributed, a gap that is widening with climate change. Desalination. Turning seawater into drinkable water is possible but challenging. It requires either thermal desalination, boiling and condensing, or reverse osmosis, forcing seawater through ultrafine membranes. Reverse osmosis is now the most common method. It separates salts by high pressure rather than heat. However, desalination is extremely energy-intensive and expensive. Roughly 2 gallons of seawater must be processed to yield 1 gallon of freshwater, driving costs and carbon emissions sky high. For example, Southern California's Carlsbad plant produces 50 million gallons per day, but the water costs about $2,200 per acre-foot, enough for a family per year, roughly twice the price of older imported supplies. Moreover, desalination generates a brine byproduct that is highly saline and often mixed with chemical additives. Studies warn this toxic waste has been underestimated by as much as 50% and can seriously harm marine life if not properly diffused. For these reasons, desalination is mainly used where no other option exists, Gulf countries, for example. It can reliably produce water, but its high cost and energy and environmental impacts mean it can't be the sole fix. Conserve and reuse first. Experts argue that cheaper fixes come before desal. Municipalities are urged to fully implement conservation and reuse wastewater, potable toilet-to-tap recycling, or stormwater capture. These low-tech measures, fixing leaks, recycling urban wastewater, recycling irrigation return flows, etc., are far less costly and can stretch existing supplies. In essence, do the easy measures now and save the expensive desal for later. Agriculture, 70% of water use. Globally, about 70% of all freshwater withdrawals go to irrigation. In places like the western U.S., now enduring a mega-drought, the driest 1,200 years, this makes farming vulnerable. For example, California, the nation's top agricultural state, uses more water for crops than for cities. Traditional flood irrigation is very wasteful. Switching to more efficient methods, drip or sprinkler irrigation, can save 20 to 30% of water while maintaining yields. Modern smart irrigation, computer-controlled valves, moisture sensors, and analytics goes further. Farmers can irrigate on demand with precision. In trials, smart valve systems have cut farmers' water use by roughly 20 to 30% simply by automating timing and flow. Overall, improving irrigation efficiency and technology is seen as a key way to turn the tide on scarcity. Innovative farming, growing food with much less water, is another strategy. Indoor or vertical farming, hydroponics, aeroponics, allows year-round climate-controlled production. These systems recycle water in a closed loop, so plants use it far more efficiently. Studies show a well-tuned vertical farm can use up to 90% less water than a conventional field farm. Companies like Ironox or Square Roots are using robots and LEDs in greenhouses or shipping container farms to grow greens and herbs with minimal waste. These methods also avoid droughts and storms altogether. In the long run, expanding hydroponics and urban farming can significantly cut irrigation demand and bring farms closer to consumers. Technology and data. A suite of new technologies can squeeze more yield from each drop. Farmers can use satellite data, soil sensors, and crop models to apply water exactly where and when it's needed. For instance, experts are developing algorithms to run what-if scenarios. How would different watering schedules affect yields? Internet-connected valves like Lumo and mobile apps give real-time control over irrigation. Even simple tools, flow meters, weather forecasts, automated alerts, help eliminate waste. One grower reported safely cutting water use by roughly 30% simply by automating timing and flow. These smart farm innovations are still emerging, but as they mature, they will make irrigation far more precise. Coordinated management. Beyond individual farms, water must be managed collectively. Shared sources, rivers, aquifers, need updated compacts and trade mechanisms. For example, the Colorado River, the lifeline of the U.S. Southwest, serves 40 million people across 7 states. Decades of over-allocation plus climate change have nearly drained its reservoirs. Solutions include interstate water markets, letting farmers lease water, and recharge projects, pumping excess rainwater into underground aquifers in wet years. Likewise, cities can expand stormwater capture, treat and reuse wastewater, and raise efficiency standards. On the policy side, governments can push efficiency through incentives or regulations, as Israel did by coupling desalination with strict conservation, resulting in much lower per capita use. In summary, no single solution will solve the crisis. Instead, we need an all-of-the-above approach. Cut waste, recycle more, farm smarter, and only use costly desalination or new supplies as needed. Conservation and smart management come first, freeing up every drop of existing freshwater. Then advanced tech like sensors, IoT irrigation, vertical farms, and engineering like desalination and aquifer recharge can fill the remaining gap. With climate change intensifying droughts worldwide, developing and combining these solutions now is essential to ensure reliable water for people, farms, and ecosystems.